Hello and welcome to the Plastek webinar. I am Mick Shaw, European Vice President for the Plastek Group. I welcome you all to our 10th webinar. In our previous webinars, we heard from many great resources from leading experts in the industry. As we are all hearing daily, one of our main drivers in the industry today is sustainability. And for those who joined our last webinar early May, will know how committed the Plastek Group are in this subject. So to follow on from our last session, which covered many aspects of sustainability, I would now like to connect you over to another of our partners and experts in the field. We were first introduced to Biome Bioplastics in 2018, partnering with them to conduct trial runs using several different compounds in our products. So please welcome Miriam from Biome. Thank you for your time and please enjoy our Plastek Academy webinar.
Hello, everybody. Happy to be here, and thanks, Mick, for the introduction. And I think before we start, definitely a big thank you to Plastek for creating this opportunity and the webinar, allowing me to speak about what passionates me, as well as professionally, but also in daily life. And you will meet her after the presentation, but also a big thank you to Nicole, because we had multiple chats in order to make this go as smoothly as possible. So let's hope you will enjoy the next 45 minutes. So we're here today to talk about biodegradable and compostable plastics. And let's see if my slide deck works. It says click and wait. Yes, there we are. So today we will start first, of course, with introducing the company I work for, Biome Bioplastics. And then I think the main question and the main topic of this presentation, and I allowed myself to be inspired by Shakespeare's famous quote, "To be or not to be." The question is indeed to compost or not to compost. And by that I mean, when are we talking about something that's compostable? When can we claim compostability? What is now biodegradable? What is the difference? What is bio-based? And the certifications that go along with that. Which brings us then to the next topic, which is why. Why should we even consider compostables as a brand, as a retailer, as an end consumer? Why should we consider buying compostables and as a converter? So I hope I can clarify that a little bit as well. And I would like to end the presentation with just very general. I will explain a bit more what our resins can make, so about our portfolio. I am fully aware we have very different people from very different industries present, so I'm not going to go in any details towards mechanical properties, but Nicole will explain after the presentation how you can download the handout where you will have all my details. And I actually already look forward to receive an email and happy to set up personalized meetings if you want to go more into any technical details that might concern your business. So, yes, the next slide, it's working. About Biome Bioplastics. A few figures, and mainly probably a few people haven't heard about Biome Bioplastics before, and probably a few amongst you have, or have even been working already with us together. But for the ones who don't know us yet, we have more than 20 years experience in the polymer sector. We are a mature company. We're not just a startup entering the market. The holding, the group itself, has over 50 people employed, and just a number on our turnover, which we are aiming to increase drastically in 2021. Last year was a bit, I think for a lot of businesses, was a bit more difficult. The capacity that we currently have, I think very important for the converters, is around 50,000 metric ton. And we have over 800 formulations in our library. A little bit more on those formulations in a few slides. I joined Biome 3 years ago, coming from another company also active in the biodegradable plastic industry. And when I joined Biome in 2018, they had 400 formulations. So you can already see it goes quite fast paced. So we are, and I just pressed enter. Yes, there we are. We are headquartered in Southampton in the UK. The group itself is listed on the AIM markets. We serve a global customer base and a little bit more in a bit as well. And everything we develop, and I think this presentation should support that. So Biome Bioplastics has decided to dedicate their entire business to biodegradable plastics. And I hope it becomes a bit more clear during the presentation why we found it was, you know, that inspiring enough to have a complete business just dedicating to that. So all we do is we develop and formulate and produce compounds that are biodegradable, and we try to aim for a very wide array of plastic processing technologies. As you can mention, I'm currently talking about biodegradable and not yet compostable. And on top of that, our compounds are partially or completely bio-based. And a little bit on that as well in the following slides. So that brings us to the value chain. And I think as everybody else in the last few years, we're aiming for a circular value chain, not a linear model anymore. So where do we find ourselves? And I think I'm going to see if I can move this. Yes, I can. So we cover everything from formulation to compounding that we then supply to our customers, the converters. Now you can already understand that in order to be able to create proper formulations, we need to understand completely everything about our raw materials, and we need to understand everything about processing at the converter side. But also we need to understand what's happening in the market. What is a drive? What is a pull? And of course, the aim is to have all those end-of-life applications ending up as compost going back onto land. So as we said before, we serve a global customer base with the main focus on North America and Europe, and North America being the key market. I think North America is just slightly bigger than Europe, so it makes completely sense. The applications we try to target with our resins is related to single-use plastics, related to food-related contact packaging. So it's straws, coffee rings, but also tea bags, cutlery, food packaging. So the typical customer that we have is the injection molder, such as Plastek, but also blown film extruders, laminators, and even non-woven producers. And there will be a nice little application, a picture of a nice application at the end of this slide deck. So with regards to our manufacturing and warehousing, so we have 3 main manufacturing locations, which is Europe, UK, mainland Europe, UK, and North America. And depending a little bit where the largest customer pool is, we aim then to produce near that customer base. So all our film grades are currently compounded in Europe. So therefore we need warehousing in North America, because of course we want to be able to act swiftly on new incoming orders and existing customer orders as well. And I think at this stage, yeah, we have at this stage basically an injection molded grades that we have compounded in North America. As for commercial and technical support, I think there's clearly a pre-lockdown COVID situation, an ongoing COVID situation, and hopefully a more positive post-COVID. So during the COVID, we still aimed to, where we really pride ourselves for, to provide that commercial and technical support, but we had to do it through the channels like we're talking now. You see me, I don't see you, unfortunately. But we tend to be, when a customer wants to trial our material, because of course bioplastics are still quite new in the market, although they're not new in development, but that's another story. We do want to be there. It's about understanding equipment, and most of the time it's just the fineness in the temperature settings in order to have a successful trial. But also if a customer is looking at an application where we don't have a compound yet for, it's about sitting around the table, looking, is it feasible? How are we going to do that? What type of equipment do you have? So we really it's our unique selling point. We really pride ourselves to be sitting down with the customer and to make it happen. I think that is, in a very good nutshell, what Biome stands for. Brings us to the main topic of the presentation today. What is now compost? What is biodegradability? And where are the true claims and where are the false claims? Because unfortunately, there's a lot of greenwashing still out there. So let's just start really simple. We all know the conventional plastics. They're not biodegradable and they're fossil based. Now, you can have these exact same plastics as still not biodegradable, but bio-based. And it means renewable materials is used to make the exact same polymer. I think the most widely known will be the bio-based PE, produced by the most widely known producer, Pacts. They are using sugarcane as a base to start making their PE. That PE can be completely recycled with a normal PE, but it will not biodegrade. So it doesn't mean if you have something bio-based that then therefore it can be biodegradable. The difference between a bio-based PE and a fossil-based PE is the age of the carbons, because the carbons of a fossil oil are just millions of years. So that's bio-based, but not biodegradable yet. Let's now shift to the other side, biodegradability. So we have biodegradable polymers, but they're still not bio-based. They're fossil-based. And I think the main reason there is because the technology is not there yet. There's a lot of work done around trying to get them in a bio-based version. So, but the main examples are there, for example, a PBAT, a PCL, with PCL even being marine biodegradable. Then we have, yes, there we are. Then we have also, for example, PBS and PBSA. They already have building blocks that are bio-based, but there's still other building blocks in the polymer that are still fossil-based. And then we have, I think, quite known since recently, the PHAs, because they're really in uprise, and the PLA, already a bit longer known. They're fully bio-based and biodegradable. Now, this is where Biome focus on. So why do you need Biome now? Well, often, for example, PLA can be quite brittle. PHA has its challenges in processing. A TPS still can be quite brittle. Often these polymers on its own, they don't really tackle a wide variety of applications you can use them in. So having that know-how and opportunity to play around with all these different polymers in formulations, you can open up so much more applications you can tackle. And that is from a mechanical perspective, but also from a biodegradable perspective, because as you see, I'm still talking about biodegradability. So all these polymers are biodegradable. Now, it also explains why our compounds are partially or fully bio-based and not all the time fully bio-based. Because if we're going to limit ourselves to just fully bio-based compounds, then we limit ourselves in offering a lot of other, that we cannot offer a lot of other formulations. But also, I think, and probably that will become a bit more clear later on when I talk about industrial compostability and home compostability, all these polymers are industrial compostable, with a little star that I explain later. But they're not all home compostable. They're not all soil biodegradable. They're not all definitely marine biodegradable. If you want to look at something that's marine biodegradable, we have the PHA, we have the PCL, and we have the TPS, and that's it. So you can then also already understand that for us, the easiest route is having something industrial compostable developed. But if we want to develop something home compostable or soil biodegradable, that's much more challenging because you often cannot use a few polymers of that. So that is about bio-based and biodegradable. And in this slide, I want to add compostable now. So what is bio-based? Well, we just said it. It's polymers that are manufactured from renewable resources. Added value, if the application ends up in incineration or it's a biodegradable polymer and it biodegrades, the carbon dioxides that are released in that process will not do anything to the burden of the greenhouse gases in our atmosphere, because you're using something from a plant resource that already was available on Earth, where with a fossil oil, you are using captured carbon dioxide and you put that in the atmosphere, which is not really favorable. So that is really the added value if you want to think as a business, you know, I want to go to a startup life, I want to go to bio-based. So what is then biodegradable? Well, biodegradable, and there's no confusion about that. Biodegradable means you have microorganisms, and microorganisms are bacteria and fungi. And depending on the environments they live, for example, in a marine environment, you won't have fungi living, but you still have certain bacteria that can live in a marine environment. Now, if those bugs, call them just the bugs, want to eat your polymer and they digest it completely, like when we eat food, so they have enzymes that they secrete and it just breaks it down in building blocks and they take it up to them because they are digesting it in order to reproduce themselves. So they create biomass out of it. In that process, you will only have water and carbon dioxide. There is nothing else. There are no microplastics, there are no intermediates, and there are no leaching products. If you do, you cannot say you're biodegradable. This is a very clear definition. Biodegradability means it's a very clean, simple chemical process. Now, you can have a biodegradability in the presence of oxygen, or you can have it in the absence of oxygen, like, for example, if you would have applications ending up in an anaerobic digester. And the process is, in the presence of oxygen, you have water and carbon dioxide that's being formed because it's just what the bacteria do. And in the absence of oxygen, you have carbon dioxide and methane that is being formed. That is biodegradable. So now what is compostable? Well, compostable is actually the same process, but in a specified time and in a specified environment. And hence where the word comes from, you produce compost. So you can never use the word compostable if it's biodegrading, for example, in soil, because you're not creating the compost. Because I think that's the main confusion often out there in the market. What is now biodegradable? When do we speak about biodegradable, and what is compostable? So to visualize it quite simplified, if you have something that's biodegradable, doesn't mean it's necessarily compostable. But if you have something that's compostable, it means it is biodegradable. So I hope this helps a little bit, taking away the confusion. So now when you know, as a brand, as a converter, as an end consumer, that if a packaging says I'm compostable, how do you know that's true? Because like we said, unfortunately, there's still quite some false claims out there. Well, there are certification schemes. And I just mentioned the two main standards, which is in Europe, the EN 13432, and in the US, it's the ASTM, the 6400. And those key tests that will make you pass or fail your compost test, where you can claim then yes or no, am I compostable, is quite simple. You have to do a biodegradation test, and whatever you submit, it needs to be biodegraded within 6 months. The conditions, they use the conditions of an industrial compostable facility, is 56 to 60 degrees, or in Fahrenheit, 132 till about 140 degrees Fahrenheit. So you don't have that outside in your garden. And you have like a little bit of a higher relative humidity. And you need to pass a disintegration test. So your application that you submit, it needs to be after 12 weeks, it will be tested through a sieve, and the particles need to go all through a sieve of 2 by 2 square millimeters. Does that mean you have microplastics? No, because you need to be biodegraded by 6 months. Now, this comes from somewhere. It's because industrial compostable facilities, it's a market segment, it's a business. And what they do is they will collect their organic waste, and you don't really see it maybe very clearly on the picture, but organic waste will be put inside. And their cycle time, it will vary maybe a little bit from country to country, but in general, it will be around 12 weeks inside before it starts to look like soil, and then they will put it outside and let it mature up till 6 months. So of course you don't want any plastic around it anymore. So that's why, in order to be able to have that waste management route available for your compostable plastic, you need to meet this criteria. Of course, at the end, you also need to do your ecotoxicity testing and heavy metal testing. There are a range of approved laboratories worldwide, and like, for example, I think the most widely known is OWS in Belgium. They have the accreditation that those testing can be used for certification. So then you have the independent certification schemes. They exist like TÜV Austria and the BBI for America, and then you have the logos. So once you pass these tests and once you have that logo, there is no mistaking, you can claim compostability, but you need to have the logo. So often you see bags and they just say it's biodegradable, and I'm like, why don't you have the logo then? Now, already understanding a timeline of 12 weeks and a biodegradation test of 6 months, we always say to our customer, be aware. even a chunky carrot would not pass these tests. We know a carrot is biodegradable, but it probably wouldn't be in 12 weeks to these smaller bits and pieces. Although, and I think this is very important for the listeners who are interested in rigid applications, this carrot might pass a test. And it's a carrot that actually comes out of my own garden 3 years ago. Apparently, when you have rocks in the soil, the carrot will grow around it. But I thought it was a very nice picture to illustrate. Remember, you have microorganisms that need to digest, eat your applications. So the more surface you create, the more bacteria can sit on it, the quicker your process will go. So having a rigid application passing or failing a test often just depends on how much surface have you been able to create in it to make it accessible to bacteria. So this carrot, I haven't tested it, but I ate it. It would probably maybe pass a test. And I thought it was a very nice picture just to show. This is actually a true picture, a microscopical picture I took. I put a reference there from a magazine in the UK. This is microorganisms sitting on polymer chains. So you can see the more surface you create, the more they will sit on it. Then they will reproduce themselves. So they make babies, and those babies will start eating more and more. So you can speed up that process. So also from our perspective from Biome, if we develop a compound, it's understanding how is that application looking, and also understanding which polymers are more attractive for bacteria to eat than other polymers, and make sure we add it in it, for example TPS or starch. So we have film grades that are potato starch based because they're very attractive for bacteria to start eating. Brings us to home compostability. So there is no standards, but in Europe there's a certification scheme, and that scheme follows the standards of the EN 13432. Basically the same rules of the key test of a pass and a fail criteria, only your temperatures are the ambient temperatures, so 20 till 30 degrees Celsius, typically 28, or in Fahrenheit 68 till 86, typical 82, and you get 12 months of time for your biodegradation. They're a bit more lean. And for the disintegration, you get 26 weeks instead of the 12 weeks. Same tests, ecotoxicity and heavy metal. Definitely for the industrial compostability, very important because those companies want to sell their compost again to the customers. So you need to ensure, that everything is absolutely fully safe. And this is the logo. Only one logo available. If you don't have this logo, don't believe. Only believe it when you see that logo. So that's about certification. Now, why? Why should we now consider these potential compostable or biodegradable polymers? Well, and I must admit, I joined the biodegradable industry in 2012. And the first thing during my training, what they showed me was the plastic jars in the oceans. There were 5, and I was shocked because I thought, I was not aware of that. How comes I don't know this? And do other people know that? And this is really terrible. This is quite bad. Now, luckily, in the meantime, we had Ellen MacArthur, a UK sailor, erected her foundation, promoting all about circular economy. We had David Attenborough really rocking the boat with his documentaries. And the awareness of plastic in our oceans have increased because there is a lot of plastic besides those 5 islands I was speaking about. Also the microplastics that are just, available even deeper in the oceans and are being digested by fishes and in the end digested by us. It's known now, it's not a secret anymore. So that has really driven not only legislation, so we have in Europe since this year active the single-use plastic ban. Really did extensive studies which applications can be avoided, which applications we need to just make more stricter and sterner guidelines. We have RAP in the UK that came into life, which is very similar as the US Plastics Pact in North America. And it's all about how we're going to solve this plastic waste issue. It's about circular economy commitments. We create something, we often still need the plastic. I mean, plastic has really done a great job the last years in protecting food, in being able to eat things that comes just from all of the other side of the world. But how do we now make sure that at the end of life, it's just not ending up somewhere? How do we make that circular? How can we reuse something or recycle something, or can we reduce somewhere plastic that's not really necessary anymore, like the single-use plastic ban in Europe? So it's about waste recovery, and it's about closing the loop. And there's a lot of attention lately, thank God, to that. Because to be honest, this is a picture you don't really want to show your children, and we're not really proud of that. And this is not photoshopped. This is a true live picture. And ideally, in 10 years, no more pictures should be able to be made like that. So recycling, because of course, even from a biodegradable point of view, whatever you should be able to recycle, you should recycle. But unfortunately, there are limits of recycling. And if you look at the data, only 20% today globally is recycled. And it has been in the uprise, like you can see, but still, we're not there yet. We're far from there. And although there's existing infrastructure, it seems that still 60% ends up in landfill. Now, I've seen some landfill piles here in the neighborhood. They're not covered. Have some wind, have some rain, have some storm. The plastic will end up in the environment, will end up in the river stream, will end up in the ocean. So, and to be honest, who wants a big pile of dirt, in a beautiful landscape? So landfill is not really the way to move forward. 25% is incinerated, and I think if the incineration process can be done very properly and contained, it is a part of the solution. So how comes the recycling rates are so low? First of all, the availability of the different polymer waste streams. We know HDPE and PET are the main ones, and PP is a little bit in the uprise, but there are a lot of polymers that still cannot be recycled at this stage. And even if we can recycle it, a lot of it is lightweight, and it's a business, it's a market segment as well, recycling. They are being paid by weight. Now imagine all that lightweight food packaging. That's not really interesting for them. And they have families to sustain as well. So what do you do with all that lightweight? And then often it's food contaminated, also for rigids. You have to start cleaning them. And so it's another hurdle. And then we have made fantastic rigids and films that are multi-layered for certain properties, but it's impossible to separate them. So recycling alone is not the answer. And that's where Biome and our partners in the industry feel you definitely have a benefit than looking at certain applications that they are compostables. Because remember, composting means organic recycling, and organic recycling is a viable end-of-life solution for biodegradable food packaging. So it is one, you avoid landfill, so it's a solution for your packaging, for your waste that is no longer waste. But something that's often overlooked as well, and this is another circular model, we grow our crops, we harvest them, and when you take them away, you have used your nutrients of that soil. So you lose soil. And beside that, you have the increasing sea levels. And beside that, you have, soil erosion by weather. So in that market segment, and people will know that, there's a huge problem. And getting as much proper good soil back into that system to put back on the lands is in big demand. So now all that organic waste that is now on that packaging is normally going to landfill. If you can capture that together with your biodegradable packaging, having that go back via an industrial compostable facility, creating soil, it's a win-win situation. And it is indeed a good way, like I said, allowing contaminated food packaging to be disposed of with organic waste. And I was just thinking I wanted to say something else. Yes, and I remember. I haven't included the data in this yet, but recent studies, and on the European Bioplastic website, you will find that, has shown that having biodegradable plastics in your compost actually improves the quality of your soil. Now look at that. How can you say no to that? So, okay, then the next topic is, yeah, fair enough. We make something that's compostable, but I don't have the route. Where do I dispose it of? I don't have the curbside collection. I don't have the industrial compostable facility. There's no point in making something compostable because it defeats the subject. I cannot get it disposed of. And it's true, it's the same as the recycling industry. We're still in our baby shoes and we need to become a child before we can become mature, but it is about moving forward. And I thought, this is a picture I only took last week from a website, an updated website. This is the industrial compostable facilities in the US. There, it's maybe not massive as of yet, but they're there. And at the green dots, as you can read, it accepts already all compostable products. So we are moving in the right direction, and having these proper facilities in place is absolutely important. And I think I got this from Biocycle. It's a quite interesting graph as well. If you then see from 2005, same here, up till 2017, the growth that has happened, as well for the communities, as well as for the households, where they have now access to curbside food waste collection, it is there. It still needs to improve much more, but there is a way forward. And we always say Rome is not built in one day, was it? Now, same for UK. Biome Bioplastics actually participated in a study a 2 years ago, supporting also the government in with all the Brexiting and whatever that was happening. They wanted to understand a little bit better, what is the potential for compostable plastics in the market, and for the UK itself. And they did some studies also in seeing how much food waste is actually generated. And you would be surprised, but 10 million metric tons of food waste is generated per year. Now imagine if you can all capture that and have it go into the industrial compostable facilities. And luckily, you have in the UK, you have the BBIA, is the Biobased and Biodegradable Industry Association. They did which we are a member of. They did a lot of strong lobby work and achieved that we finally have a mandated residential food waste collection in 2023, which is also already present in Europe. So you're creating again that waste collection, because if you don't have the waste collection, you need to have all the parties in place. Now we have many more industrial compostable facilities, but we have 120 that are certified, meaning they are allowed to sell the compost again, and 53 of them are already accepting compostable plastics. So I think it's positive numbers. Brings us to our portfolio. Like I said, it's going to be a little bit more high level. So what we do is we formulate solutions. We do aim to have a direct replacement for existing conventional polymers. It wouldn't be nice if our customer would need to buy completely new equipment in order for our polymer to be processed. So we do aim to have a drop-in solution. We focus on the technically demanding markets, and I think on that note, we are in the process. It's an ongoing R&D project, where we are developing home compostable compounds for fibers, tackle home compostable fabrics that can be woven or non-woven, and one of them is tea bags. It's not out there yet, so like I said, we like the little technical challenging applications, and if you can achieve that, is very fulfilling. Then, so like I said, we developed a customized formulation. So we have, of course, our off-the-shelf compounds, but if there is an inquiry, with of course not a few 100 kilograms, but preferably a few 100 metric ton, but still it's not that big compared to conventional plastics. Opportunity, we sit around the drawing board, we see what is possible, and we start formulating, then we start trialing, because in Marshwood we have our own little compound pilot line, and our lab blown film line, and our injection molder. That's what we have in Marshwood, besides our laboratories. So we will then start compounding, we will start testing it before then it goes to the customer to test it a bit more larger scale. So, as we said before, our knowledge covers everything from raw materials and production through to processing and storage. So we focus on technologies such as blown film extrusion, injection molding, Plastek, sheet extrusion, and non-wovens, and now also the fiber for the home compostable variant. So just some brief pictures on applications made by injection molding and sheet extrusion. Just that little cup was just like a show and tell on an exhibition. This is just a little tray to show you can make the trays out of it. This is about the flexibility, so the tomato clips, so when then the tomatoes are picked and you have the remains, you can collect it all together and it can go to an industrial compostable facility. Just a pen, because you need something to show to people. Razors, we actually have a customer that believed having industrial compostable razors or biodegradable razors is an added value, but you can make with it. And this, I think, is one of our biggest prides. This is a ring where we developed a compound for. It's industrial compostable. The lidding, we have one part is the sealability. The other part is, and a name that you probably will pop up often if you're looking at compostables. The other part is for the barrier is a NatureFlex film made by Futamura. And then we also developed the compound. And we hit a hurdle there. And there was not really a company interested trying to make an nonwoven, so we decided to take charge ourselves. So we just rented time on equipment, and it took us about a year and a half, 2 years, but we came up with this officially industrial compostable coffee pot that is in the North American market. So we actually are also producing this nonwoven in this case, which is high heat resistant because it's coffee and it's thermoformable. Then to the filmic applications, bags, like I said, for the barrier, because of course biodegradable plastics are very breathable, which is often good for certain applications, but you don't always want that. You want a shelf life, you want barrier properties. So we did a quite nice project end of 2018, and here you can see the name together with NatureFlex, because they're a UK-based company as well. Well, they were Innovia Films, but taken over by a Japanese company called Futamura, but they're still UK-based. So they make, and I think they're the only company, they make a cellulose-based film that is home compostable, even marine biodegradable, industrial compostable, and has quite nice barrier properties. Where we then come in with our resin, if a film is made out of it, is very good sealability, good puncture resistance, and a soft feel and touch. So we actually did a project together to make a proof of principle, and we made those pouches in the UK. Gloves, but also bags. I have not put it on here, but anything related to film, but it's pouches. I think any dry coffee bags and any dry food pouches, even oily content is allowed, can be tackled with our resins. That is a little bit about compostables and Biome Bioplastics as well. And as see, I sit perfectly in time, 39. So I'm gonna now be happy to introduce you to Nicole, who will also let you know where you can get the handouts with some more details if you want to contact me after the presentation. And I do hope I have been able to inspire you a little bit about the added value of compostables. Up to you, Nicole.
Thanks, Miriam. And hi, everybody. My name is Nicole Freeman with the Plastek Group and the Plastek Academy series. So thank you all for joining us today. As Miriam mentioned, we will move into the last session of our segment of our session today and wrap things up. It was a pleasure to have Miriam from Biome Bioplastics with us, who is an expert and passionate about the topic, helping us kind of work backwards. I think, you know, she mentioned we have a lot of individuals from different markets, different areas of the globe looking for information on this topic at different stages within their operations and interest in the topic. So again, thanks for helping us kind of work backwards from already sampling things to then understanding the time frame, the scientific background of how we can find what's available to help us meet the means and the goals that we've all set for ourselves. So to our viewers, we want to open this last few minutes up to you to ask questions that you may have been asking from your coworkers, from your technicians, from your purchasers, or anybody who's looking to educate their family at the home place, like Miriam said. So you can see on the screen here the instructions if you're not familiar with our platform, where and how to write in your questions. We'll take a look at those, see if we can answer a couple. And then while you're doing that, before you leave the webinar today, please do go to the handout section. We have uploaded a couple of PDF documents, And in order for those to be available to you after today's webinar, you want to make sure you just click on those and let that additional window pop up so that you have that after we leave today. All right, so Miriam is back with us and I see some questions coming in. Let me just take a look here.
I just had a quick sip of water.
All right, so our first question from the audience is, do you have a polymer that uses a byproduct or waste as a raw material to produce it?
Like I said before, so we buy the PHAs and the PLAs and the PBATs from our suppliers. So the question is, do those suppliers use waste? I know for the PHAs, for example, they're looking into that. There are a lot of small startups that are looking at using wastewater or waste from lignin from waste. But at this stage, I think they're like Hanika and Danimer is still being using or the canola oil or the palm oil, because it's quite. It is a very good question because it's in the end the aim, but it's quite difficult to make a polymer that serves mechanically properly because your waste is a very variable feedstock. So having a consistent feedstock is quite important in order to enter the market. But I know the plans are to start looking at waste. Our GM-free potato starch, is that coming from waste? No, it's just a potato itself, but it's not eatable potatoes.
Okay. We do also have some questions about the different types of resins and then how they can transfer over to certain applications or markets and the products within those markets, but I'll get that next. But I want to go back to one question, sticking with the type of materials. An audience member is suggesting or asking your thoughts and opinion on possibly using seaweed as an ideal solution for injection molding, or using non-food crops to avoid water abuse and getting compostable bioplastics.
So yeah, I know the question on seaweed is often out there, but currently we just really are focusing on the polymers itself, and if there are any new available polymers, which we often look into, like PGA is quite new that we're looking into. So but we don't make polymers ourselves, we are a compounder, so we're not a raw material supplier. We will buy the whatever there's available, we will screen, and sometimes they pass and sometimes they don't, because you need to have something that works mechanically. But we buy them and we blend them, so that's what we do. We don't alter the polymers, we just mix them.
Okay. All right, so on the material, what is challenging for compostable material or compostable packaging?
That's a very broad question.
Yeah.
What is challenging? I think if you look if it's food packaging, then the challenging part is indeed the barrier properties, where I explained, then you often have to start making, the multi-layer structures. From a price perspective, and that probably is also important. Of course, biodegradable plastics are still produced much smaller scale than conventional plastics, so hence our production costs are not optimized as of yet. So that makes a compostable option 4 times more expensive. So that is a challenge often for to make a decision, let's move forward with the compostables. And then as well the disposable of it. So as I've shown, it is in the uprise, but there are areas out there in the countries that don't have that curbside collection as of yet, and then the brand feels like, well, there's no point in having something that is industrial compostable because it's going to end up in landfill anyhow. And landfill is still not a solution, because often I do get a question. So if something ends up in landfill, if you have a compostable, then you're a bit more safe than a conventional plastic. No, because you really need that right environment for a biodegradable plastic to biodegrade. And in landfill, we even have reports that you find a newspaper printed in the 30s. Now we know a newspaper is very biodegradable, and that didn't even biodegrade in landfill, because you need that. You need that favorable environment. So that those are challenges at this stage.
So switching gears, I mentioned I wanted to get back to, we talked about the materials, how it's made up, how we can find it as a resource, its accessibility to it. Jumping gears to the other side of actually using it. So our audience members are curious in any clarification or use cases that you've seen it in for, say, sterilized items, such as in the medical field, hospital applications, sterile packaging and instruments.
I actually do get quite often inquiries coming from the medical world. There, the challenge I always pose to the customer is, what do you see as end of life? Do you really want that to be collected with organic food waste? And then it really depends where it has been used. If it's just like a wrapper around, a needle that hasn't been contaminated with any viruses or whatever, fair enough. And then I think lightweight packaging definitely can find its way. But I think with the medical applications, we have to be a bit, we have to be a bit sensible which application. I think in general, incineration should be more preferred route.
Okay. I want to ask about, you went over in one of your last slides the different technologies and applications that your materials can be used for in your portfolio, injection molding, blow molding. So I know one of our audience members is utilizing blow molding and questioning what is the best or suggested material for blow molding purposes. And then I'd like to double up on that and just reiterating, what are the main applications on the market that Biome is supplying its resin to? I know some are still in development, some are in development further than others. So what is available for blow molding, and then the one that's most available that you are supplying its resin to our industry?
So for the blow molding, we have 4, 5 very lovely grades. We have industrial compostable ones, and we have home compostable ones, and we even have one grade that you can use as a monofilm or in a coax structure to create transparent home compostable film. But if you would like to know more about our portfolio, please do drop me an email and I can share you some more details. But beside that, so besides food packaging, which, like I said, it's everything that's contaminated with food and everything that is lightweight is definitely a go-ahead for compostables. So our focus is highly on that, but also on the rigids, anything that's single use or comes in contact with food. So it is the coffee pots. We're also looking, of course, at the coffee capsules, like a lot of companies are doing. It's a straws, it's cutlery, it's anything that you have like food on the go that needs something to contain it, but then it's being disposed of. Those are our main targeted applications. Doesn't mean we're not looking at also waste bin liners, shopper bags. I even have an interesting customer looking at potato packaging, because it's potato based, our film grades, and then it has potato packs and potato packaging. And then after the use, you peel your potatoes in the bag and you can just put it all in home compost, because it's a home compostable version. But yeah, anything related to something that cannot be recycled and is contaminated with food has our focus.
Okay. All right, thank you for those answers, Miriam. I was just scrolling through the other questions that we did not get to today. There is a combination of some, asking about where can we recycle and compost for those that don't have availability in their communities. So again, check out those handouts that Miriam included for us today. I'm sure there's some information in there. And then just expanding more on the regulations and
drop me an email and I'm happy to answer.
Yeah, so we will wrap this up today. I think there's some duplicate questions in there. We'll definitely get back to the ones that we were unable to answer, but kind of covered a little bit of each of those. So hopefully, again, we've presented to guide you in the right direction to find some more information as a resource. And again, knowing a little bit of the background to help us continue reach our goals and understand the availability of things to do so. So Miriam, I'll let you have any final comments before we close out here today.
I still want to thank everybody for being present, and I think, yeah, from my point of view, I always say what we do today, our actions today have an impact on tomorrow. So considering, and if I even may say embracing compostables as a part of the solution to tackle the waste problem will provide the opportunity to create a beautiful future tomorrow for our children. And to quote David Newman, our managing director from the BBIA, everything is connected. Thank you.
Wonderful. So with that, again, thank you to everybody. The last slide here that we have will also help answer some of those additional questions I see popping in that we did not answer. So be sure to check out the handouts. This will be available for later viewing at your convenience. It is being recorded, so we'll have that up shortly at plastekgroup.com/plastek-academy, or our go-to stage on the GoToWebinar platform. So check that out, share it with your organizations, your students, your, anybody you have who could benefit from this presentation. Check out some of our previous webinars and then the couple that are left to come in this series. We had some about carbon footprint questions. So we had another webinar presentation a couple months ago that could possibly help answer that question as well. So again, feel free to visit back with us and take our contact information for any follow-ups. And thank you again. We look forward to seeing you in the future and forming mutually beneficial relationships to help you in your everyday operations. So thank you all. Thank you, Miriam, and thank you, Biome Bioplastics.
Thank you. Bye.